Good morning. My name is Len Pettis. I'm the Deputy Sector Navigator for Doing What Matters for Jobs in the Economy, Energy, Construction, and Utilities in Orange County. I'm privileged to have two of my colleagues up here on stage, Dr. Mark Bachman from the University of California, Irvine, and Kimberly Crawford from Siemens Corporation. Thank you. To key this up, how many of you saw the keynote this morning? A few of you did. Some of you missed it. What we hope to do in this session is, because we're between you and lunch, we're going to feed you, but we're going to feed you information. We're going to hopefully feed your brain. And to begin with, I'm going to show you a short little video, really because it's a work in progress. And if you heard Jamie, he talked about how we have to think differently in how we deliver education. And how we deliver the message for education is also, we have to think about that differently. So this is a little bit more of a traditional video, and we are going to layer on some young people and some students. We haven't had a chance to film yet. But I want to take a few minutes and show you that video. So before I do that, I want to cue things up a little bit and give you a preview about what you're about to experience. So we're going to go on a journey. I think we've all heard the expression, the sky's the limit. I say, well then, how do you explain footprints on the moon, tire tracks on Mars, and we have a spacecraft hurling at 9,000 miles per hour headed towards Pluto, due to arrive July 4th, 2016. So maybe the sky is not the limit, like Jamie suggested to us. We don't know what our limits are. And certainly the young people that we're in the process of helping to learn to get an education, they see no limits. So hopefully you can think in that direction. So one of my heroes is Warren Buffett, not because he's wealthy, but because he has an attitude. He has an attitude about life. When I heard his interview with Leslie Stahl about 10 years ago, she asked him, you know, you have everything. You're very humble, you drive yourself to work, you can do anything you want, you don't have to work. What motivates you every day? What do you do to get going? And he said, well, I just wake up every day and try and learn something new. And that just stuck with me. I said, wow, what a way to think about the world, to wake up every day and try and learn something new. So hopefully in this session from my two colleagues up here on the dais, you will learn something new. Mark's going to take us on a journey through the Internet of Things. He's going to throw some numbers at you, some numbers like, and you should remember these numbers, 4, 7, 17, and 50. He's going to tell you how they're relevant to all of us and our children in the world to come. And then we're going to turn it over after Mark is done telling us about the Internet of Things. And we're going to learn about what's happening here on planet Earth with one of the largest employers on our planet. And you heard a little bit about that today from our host about what the Siemens Corporation is doing, particularly here in California, and what their needs are for new workers. And so Kim is going to give us some numbers to work with too. And so Kim's numbers are 12, 18, 67, 348,000, and 76 billion. So I think hopefully at the end of our session here, you'll understand, why those numbers are important for all of us to have an understanding for, and hopefully that will help in your job and what you do. So if I can take a minute now and ask our folks to run the video. So here's one of the things that we're trying to do, and I really would love to have your feedback. You like it? You don't like it? Great thing I heard from Jamie, which I'm going to have to use all the time. I no longer fail. I'm just in my first or second iteration, so I'm not failing at anything. So this is just the first iteration of our communication. So help us make it better. Can we roll the video, please?
One of the things that I always tell my students is that this sector, energy, is something that we've needed for generations, and we're going to continue to need it. This is not a job that's going to get outsourced to India, to China. They're always going to need workers right here working on the lines, working on the energy systems here at home, and this is a job that is here to stay.
I feel that it's very important for all students to be aware of the solar industry. Our energy usage and consumption in the world today keeps growing all the time. We can't have enough renewable energy to offset our usage of fossil fuels. But with time, it's going to grow. It's going to stay with us, and it's going to be part of the mix of energy from now until forever.
The most effective energy for the future, my favorite source is the sun. It's on every day, all day long. And because of the sun, we have tidal cycles, which means the sun actually is wave energy. Because of the sun, we have differences in temperature that cause wind. Wind is sun energy. So the sun really is it, if you ask me.
If I were to give advice to anybody as for a field of work to go into, would be definitely water. Water distribution, water treatment. Water is something that we all use and need, and we have to learn how to treat it and reuse it. We need to develop new technologies in conserving water and recycling water.
Well, one of the things that really strikes home for me working in the water industry is the absolute vital nature of the service that we provide. How long can anyone survive without water? Because the water comes out of the faucets in our house, and it's automatic. It's something we just take for granted. That's not the case through most of the world. In fact, every day, 4,000 children die around the world from waterborne disease. It doesn't happen in the United States, and that's something that I'm very proud of.
We are a partner with the local air conditioning refrigeration union, so students will sometimes go into the apprenticeship of the union. So we've got a lot of students that go as entry-level mechanics, engineering, sales, administrative role, project management. We try to send our students to Cal State LA as one of the schools that has an industrial technology program, so they can take the air conditioning classes from here, and if they've done their general ed, they can enter as a full junior into Cal State LA, and so they just have the senior year to complete to get your bachelor's degree.
When I was in high school, I actually didn't know what engineering was, but I did know what inventors were, and I really liked the idea of being an inventor. When I got older, I realized that engineering was what I had been thinking of.
I love being able to create and share a vision about energy infrastructure projects that serve the communities that we live and work in. If you want to get into engineering, I would recommend that you find the company, find the job, find the person that you want to be, and do your research and figure out how to work your way backwards.
All right. What do you think? All right. Like I said, first iteration, work in progress. What's missing? We need some young people in that. So Felicia, we're going to have your boys in this. Felicia has two young ones, 5 and 6.5. So that's really what we need in this video to make it interesting. Okay, so we're going to start off our panels. I'm going to start first with Dr. Mark Bachman. I'll introduce him momentarily, and then we're going to, if there's some real burning questions, I'm going to help facilitate that. So I'll walk around with a microphone. Don't be bashful. Do ask the questions. We'll have a short term for questions at the end of Mark's, and then we'll let Kimberly Crawford do her presentation, and we'll have questions after that. And then we'll have an opportunity to ask both the panelists any additional questions that you might have. So that's the way we'd like to go this morning. And so let me begin by first introducing Dr. Mark Bachman, professor and passionate innovator, entrepreneur, teacher, and mentor. Mark professional focus is on building value in teaching, developing, employing technology, and the Internet of Things. Mr. Bachman, his current professional activity is co-founder and CEO of InXus. It's a startup interactive company, one of the most exciting startups in the Internet of Things. He has brought several university technologies into the commercial sector through starting startups that he has formed, as well as companies that he consults with. Mr. Beckman is a unique experience and insight into the issues associated with bringing early-stage technology out of the university into industry, and has published over 70 peer-reviewed papers in science and technology journals, and had issues over 12 patents, and gives scores of invited talks, like this one, each year, domestic and internationally. Mr. Beckman is awarded the 2003 Outstanding Professor in Engineering at UCI, and his teaching accomplishments is awarded the UCI Innovation Award in 2005 for his research accomplishments. Please join me and welcome Dr. Mark Beckman. Mark.
Hi, thank you, Len. Great, well, thank you for having me here. I'm really happy to talk about my favorite topic, which is the Internet of Things and how it relates to manufacturing and the future for us and for our children. I'm calling this talk Working in the Age of Disruption, and we are entering an age of disruption. I'll tell you a little bit about that. First, this is where I work. I'm an entrepreneur, but I also still work at the university as a chief technologist for this institute, which is the California Institute for Telecommunications and Information Technology. It's one of 4 major institutes funded by the state of California, focused on bringing cutting-edge research out of the universities and bring it into society so it can be commercialized and put to good use. And I spend a lot of time thinking about technology and trends and bringing communities together. All right, so let me, now I'm sure everyone in this room knows what the internet is, right? This internet sort of dominates our lives these days. Let me tell you a little bit about the internet. We are seeing a transformative time as it relates to our online presence. We are now in a time where electronics is extremely cheap. Our manufacturing has gotten so good that we can produce extremely powerful electronics very, very cheaply. So what we say to people is electronics is commoditized. It's a commodity now. We also now have a global telecommunications infrastructure. That means we can connect to anywhere in the world, literally anywhere. I spent some time in Swaziland working down there to help them with their IT issues. Swaziland is one of the poorest countries in the world, and everybody there is on Facebook. They have their cell phones. I was in Afghanistan working on a solar project there, one of the most worst places for infrastructure, but everybody has a cell phone. So we really are globally connected. And we now have an entire generation that has grown up never knowing a world without technology. So we have massive acceptance of technology too. So these 3 things come together to create a very unique situation, sort of a perfect storm for what I'm calling the Internet of Things. So let me introduce the Internet of Things. You know the Internet today, most of the data on the Internet is created when we go on our emails or we do our texting or we go on Facebook and so forth, Snapchat and so forth. And, or when we're watching Netflix or Hulu, we're getting that data from the internet onto our devices. So most of the data on the internet today is either generated for or consumed by people. So we could say the internet today is the internet of people. But that's all about to change, because in the future, most of the data going on the internet is not going to be generated by people. It's going to be generated by your house, or your car, or your hospital, or the transportation grid, or the energy grid, or it's going to be generated by your office complex, by the sewage systems, and so forth. All of these things around us are going to be generating data. Not just a little bit of data, at least 1,000-fold more data than we're generating now. And not only that, most of that data will never be seen by another human being. It'll be seen by computers. It goes straight to other machines, basically. So the data will be generated by things and consumed by things. And when that happens, we have the Internet of Things. And that's why we call this Internet of Things. We're talking about a world where we're generating over 1,000 times more data than we're generating today. But it's all generated by objects and consumed by objects. And this is definitely coming. There's no question about that. And why is it coming? Well, when we have massive amounts of data, we actually have the ability to optimize at a level we've never been able to optimize before. If you think about it, most of the things we do are inefficient. Most of the things we do are not optimized, whether that's manufacturing, whether it's putting goods in a retail outlet, or whether that's transportation. And the reason it's not optimized is because we don't know everything. We don't know what's going on. We don't know that there's a traffic jam 3 miles ahead, or we don't know that there's a problem with our operations over in China or whatever. We just know what we've got around us, and so we optimize locally. But when we have data on many, many things, then we can optimize on a much higher level, and that brings a lot of value. And so there's a big interest now in generating data from our infrastructure, from our parks, from our agriculture, from our transportation, from our cities and so forth. Because when we have that kind of data, now our operations can be optimized at a much greater level. And this means a lot of value. In fact, the value is so high. These are some of the numbers that you'll see if you start researching the Internet of Things, the kind of value that people are quoting. And these are not numbers that I come up with, some crazy tech enthusiast. These are numbers that the Wall Street Journal, Accenture, the major think tanks who think about financial issues are quoting. The numbers range between $7 to $17 trillion by 2020. Now, 2020 is only 4 years away, right? So that's an amazing number. Those numbers are so big, I don't know how to think about $17 trillion. So to put it in perspective, the US GNP is $17 trillion. So we're talking about a market that's opening up that's as big as all of America. Or another way to put it is we're talking about a gold rush. And that's what we're seeing, especially here in California, where we have a lot of interest in IoT, Internet of Things, a true California gold rush. And it's happening right now, folks, right now. So I have long lectures on this. I'm not going to give you a long lecture today because I want to focus a little bit on some specific issues in the manufacturing sector. But here's some numbers you need to know. Len alluded to some of these numbers, okay? The first number is 17. That's the predicted size of the IoT market by 2020 in trillions of dollars, not billions, trillions, okay? 50. This expected number of devices that we are expecting to have connected to the internet by 2020, 50 billion devices connected to the internet, all generating data. 5, actually it's 4 now, the number of years between now and 2020. So we're talking about escalating a lot of activity in the Internet of Things in the next few years. So whether you like it or not, this is happening. Oh, by the way, I just want to point out, on that 17 trillion, which was Cisco's estimate, Cisco estimated 17 trillion, in their analysis, only half of that is new value, new funds. The other half is money changing hands. That means companies that don't evolve, losing their value, and new companies that do evolve, taking their value. So money changing hands. So that means even if you don't want to pay attention to this, you're going to have to pay attention. This is what's happening. All right. Let me just give you a very quick example of what we're talking about. IoT allows massive large-scale optimization. And I have a lot of examples that I'd love to show you. I only have a short amount of time to talk to you about it, so I'll just kind of skim through this. So, for example, if we've got a warehouse, for example, and we need to, we're using too much energy, there's a spike in the energy grid, and we need to drop the energy usage, so we're going to contact the warehouse manager. The warehouse manager is going to reduce his energy, but if he knows all of the power consumption going on, at what time, where people are, he can reduce that energy effectively. In manufacturing, right now we have, on a typical manufacturing floor, we may have 100 sensors. That's going to go to 1,000, maybe 10,000 sensors on the manufacturing floor, so we can monitor everything going on the manufacturing floor and optimize that. Transportation, we're already seeing this is actually one of the first places where IoT is really making a big impact, tracking everything going on with every service vehicle out in a fleet, where they are, how fast they're moving, how much fuel they're consuming, and so forth. And that's already saved hundreds of millions of dollars for the companies that use that. So the way I like to describe IoT is like we're optimizing a chess game. It's no longer we're just like, oh, I'm going to save money by turning the lights off. That's not how we're going to save money. We know if we have all of the data and we have models and we have good software, we're going to save money by leaving the lights on, even though that might seem like it's wasting money, because we know, for example, that in 15 minutes we're going to have a rush of people coming in and we need to have everything ready to go when they come in because of our data and so forth. So it's optimizing at a different level than we're used to optimizing. But you only get that if you have lots of data. So, it's a really interesting thing to talk about how we do this and machine learning and these kinds of stuff. We won't get into that today. All right, now something else to be aware of. This is transformative. This is a very disruptive thing that's happening. In many ways, it's a revolution. And anytime you have something this disruptive, there's going to be unintended consequences or unexpected consequences. We don't know all the things that are going to happen. So we have to be ready to, and knowing that, that things are going to be happening that we don't have control over or we can't predict in advance. And that's just the nature of a revolution. All right, now let me talk a little bit about the largest vertical sector in IoT. If you take IoT, $17 trillion, and you pick different verticals like transportation, home automation, and so forth, agriculture, the largest sector is actually manufacturing. That's going to be the one that has gets the most value out of IoT. So I want to talk a little bit about manufacturing and how it benefits from IoT. So let me give you one example. In the manufacturing floor, there are literally hundreds or even thousands of electric motors. And these electric motors are moving things like conveyor belts and blowers and pumps and these types of things. These motors are everywhere, okay? Now, if a motor breaks down, someone has to go and replace that motor. And that means you have to stop manufacturing for maybe half an hour, maybe an hour or so forth. If you stop manufacturing for an hour, you're losing millions of dollars, right? So there's a huge value in being able to predict when the motor is going to fail, okay? So we call this predictive analysis. Now, how are you going to know in advance when a motor is going to fail? Well, the most common way is to listen to the motor. If you drive a car and your car is starting to vibrate in a funny way or make a funny sound, you know I better take that in to see the shop, right? So we can put sensors on all those motors, right? And those sensors can be listening to the motors and looking for anomalies and looking for ways that the motor is now behaving that's unusual, that's indicative of a future failure. And if we have all that data, now we're monitoring thousands of motors with thousands of computers monitoring that data, telling us motor number 7 is probably going to fail in 3 days. So we can come in and schedule that maintenance when it's the appropriate time and not have to react to a broken motor. You can imagine the value that brings. That's a huge amount of value. Very simple example, but one that I think we all can get right away. Now, in the past, in the early days of the Industrial Revolution, and we're about to enter the 4th Industrial Revolution, by the way, we call this Industry 4.0. But up until now, the worker in the factory is primarily valued because of his hands. He's basically a glorified machine. But the work of the future, we're going to value because of its brain. Now, as we move to more automation and more robotic, the human worker is going to be valued more because of its amazing assets, the ability to monitor things, to think, learn, and adapt. Human beings have powerful pattern recognition. Human beings are highly mobile and autonomous. Human beings have the ability to troubleshoot. They have contextual awareness, ability to use wisdom and judgment, ability to draw conclusions, and the ability to make decisions. These are things that machines can't do very well, but human beings can do this very well. All human beings can do that. And so we're going to want to see more and more of this asset, this feature of human beings when we utilize our workforce. So here's an example, a scenario of where we might have workers who now are taking a more supervisory role on a manufacturing floor. So here's a floor, and here's our worker, and the workers are now augmented with technology. For example, in this scenario, this worker has wireless computing in his helmet, and we've got video imaging and thermal imaging and augmented reality glasses and microphones, proximity sensing, ear protection, acoustic sensing, and ID beacons. So now this worker is a super worker. They can do so many things when they're on the floor. And we would consider this the ultimate manufacturing asset. So here, for example, I don't know if this has a laser, I guess not. But you can see on the top left, the workers now can see problems as they arise. They've got the ability to communicate those problems immediately to their supervisors or to the to the system. Many of them are doing training as they're there through their virtual reality or their augmented reality and so forth. As they move on the floor, they're able to communicate directly with the equipment, with other workers and so forth. And their workstations are gamified, so they're now seeing the direct results of their productivity, and they're able to optimize, and their environments are suited for them. So we can imagine a very different type of workplace rather than just human beings being prized for their hands, but human beings being prized for all the things that they can do. Now let me just wrap up and tell you a little bit about how we need to prepare for IoT. IoT is indeed the biggest revolution in recent tech history. There's no question about that. But what people don't realize is the Internet of Things is not about technology. Because technology is commoditized, as I said at the very beginning. Actually, the commodity is already cheap. I mean, the technology is already cheap. IoT is about the applications, is what can we do with this technology? And frankly, it's about data. It's what does data allow us to do? If I suddenly know 100 times more than I know now, how can I use that information to make a better operation, more efficient, or more optimized? Okay, and so when we're training our next generation of leaders, that generation needs to understand data. They need to understand how data is created, how data is transported, how data is used, and so forth. So we can start at the data where we create data, where we harvest data. So the types of devices such as these that are able to generate data from the real world. And the fun thing about these are all easy to use, student level electronics that are now widely available. I wish I had this when I was growing up. They have them now, cheap, easy to use devices that allow you to build your own data harvesting systems and test them out and try things out. But it's not just data harvesting. We've got to transport that data. We've got to move that data from one point to another. So we have to understand how data is moved around, And we have to reduce that data, manipulate that data, and store that data. And how is that done? And we have to understand how to analyze that data. Just because we have data, what do we do with this? And one of the things that we're very poor at is understanding how to analyze data. We don't get a lot of training on that. My daughter is learning how to divide polynomials. That's actually not that useful. I mean, it's a great mental exercise. I'd much rather she learn about data and how to visualize and communicate that data. Because even if we can draw a conclusion, we need to be able to communicate that with other people. And we're talking about a whole new level of communicating data, because the data is very, very complex, very multivariate. How do we communicate that? So our next generation needs to know how to do all of this, because the Internet of Things is coming. And of course, other issues such as protecting data. How do we protect the data, as we move forward? Okay, so just to wrap up. Okay, there's a storm coming, there's no question. This storm is called the Internet of Things, all right? And like any storm, it's turbulent, okay? But it's gonna rain. It's gonna rain money. There's no question about that. $17 trillion is not a small number, it's a big number. The only problem is, because it's a storm and it's turbulent, it's unpredictable. So I can't tell you where to put your bucket, which is the #1 question I get asked, once they find out about this, okay? So it's more important than figuring out where am I going to put my bucket. What job am I going to do that's going to make me a lot of money in IoT? It's more important to be agile. It's more important to be able to move as the situation changes. Frankly, the students that I train right now, in 2 years, what they learned is obsolete. So we have to focus on the foundations. We have to focus on the things that allow them to pivot, allow them to be agile. So they have to learn problem solving, they have to learn teamwork, they have to learn the basics. If I teach them a specific programming language or a specific type of technology, I'm not doing them a favor. All right, but in California, we like storms because we get big waves, right? And we can go surfing when we have a nice storm. That's always cool. Here's the guy surfing, having a good time. But there's a funny thing about surfing. You don't get to surf if you don't get on the surfboard, right? So you got to get out there, and if you want to ride this wave, you got to get on the wave, and it's kind of scary to do that, So does that mean we're going to be left behind because I'm afraid to get on this wave? Well, we can ride together. We can help each other out, right? It doesn't have to be solo effort when you get on that wave, and that's what we're all about. What I'm about is let's make this something we can all do, especially here in Southern California. Let's ride this together. Let's help each other out. At UC Irvine, at Cal IT2, we're big onto creating this ecosystem for IoT. That includes market, research, applications, and education. We like to work with our community, work with our partners, work with everyone to try to make getting on this wave a lot easier for everyone. So there you are. That's what we're looking at. It's a very exciting time. It's also a very scary time, but it's something that that our children are going to be going into. So things are happening. Thanks very much.
Thank you, Mark. Questions for Mark? We'll take a couple of quick questions now, if there are any. If not, do we have any questions? Going once, twice, 3 times? All right, you're all experts on the Internet of Things. That's fabulous. Okay. All right, now I'll take a minute and introduce our next speaker, Kim Crawford. Kim is the National K-12 Business Manager for Siemens Industries Incorporated in the Building Performance and Sustainability Division. Her 20-year portfolio career in communications, including broadcast journalism, provides a foundation for her success in sales, marketing, and her current role. Ms. Crawford is the Siemens K-12 customer service representative across the entire United States, and is delegated with business partnerships with Siemens, bringing them in contact with our educational system. Ms. Crawford completed her MBA at USC Marshall School of Business, right here across the street, and professionally entered the sustainability movement in 2006, helping promote ecologically minded nonprofits and helping them with their green messaging. Ms. Crawford has worked as a sustainability consultant specializing in LEED certification prior to her joining the Siemens Corporation in 2009. Please join me and give a warm welcome to Kim Crawford.
Thank you, Len. Thank you for having me here today. We're just one company, and I'm going to talk about the company that we are, but we're just one company that needs more forums like this to herald the call for workforce development. Siemens is a recognized leader in technology, and we are here to help education partners in developing the 21st century workforce. Len mentioned some numbers, and I'm going to present you with them today. So, by the numbers, we're the second largest conglomerate in the world. Yikes. Does anyone know who the first is? That's right. General Electric is the first. We have a $76 billion market capitalization. We're pretty big. We are a workforce-eating machine. We are the 18th largest employer in the world, and if you take out governments like the government of China, the government of India, we're actually the 8th largest private employer in the world. So that means we've got about 350 global employees. A 167-year-old company. We've been doing this for quite some time. Founded by von Siemens, right, way back in Germany 167 years ago. An inventor, basically. I loved the video that we saw earlier that said that this young woman loved inventing, because that's what our company is all about. In invention, we spend $12 million a day just on research and development, and we hold 60,000 patents. I'm really proud of this last number. We're number 1 on the Dow Jones Sustainability Index, and that's a judge of companies that are striving to be most green. Now, I know that on the continuum, there's dark green and there's light green, but I think that's pretty dark green right there when you're number 1 on the Sustainability Index. So what makes us tick? We talk about brand. And you'll have to forgive me. I get a little businessy, buzzwordy every once in a while, so I'm trying to tone that down as much as I can. But really it boils down, when we talk about brand, we have to talk about what makes us tick. Now, most of you aren't going out and buying Siemens products. I mean, yeah, we used to sell washers and dryers a long, long time ago. We got out of that industry, and we're really a business-to-business brand. So you won't buy products or services directly from us, but you'll certainly benefit from them down the line from the businesses that serve you. And finally, we develop innovation for groundbreaking technologies and expertise, and now brace yourself for the Asians, right? Electrification and automation enhanced by digitization. And I think that Mark would agree that a synonym for the Internet of Things is digitization. Siemens understands the importance of the Internet of Things and the digitization across all of our industry sectors. And I'd like to talk about some of the businesses that we run. Now, this isn't a commercial for Siemens. The reason I'm telling you about our company is so that you understand the need that you're about to fill as educators. And this is, again, just one company of many that has such a vital need. So we're in the power and gas businesses. We bring products and services to industries that power the world. There's an estimate that energy consumption worldwide is going to double in the next 35 years. Double in 35 years. So Felicia's got 2 children. They're 5 years old. When they're mid-career, the energy need will have been double what it is right now. So the work that we're doing to support that industry is very important. We were recently awarded the largest onshore wind contract in the world. And does anyone know where that might be? Onshore. It's in Iowa, right? A 1,000 megawatt onshore wind project in Iowa. And we actually broke the record for the largest offshore wind project, and that's off the coast of Great Britain. Everyone sees those windmills, if you will, right? Those wind turbines set in the ocean. Those are Siemens. For energy management, we help utility grids function more efficiently so that you have less brownouts and less blackouts. Building technologies is where I work. And a recent study has proven that in construction, 60% of all construction is planned to be green or sustainable. And finally, in mobility was mentioned the work that we do out of Sacramento. We do build light rail and bullet trains, and we're hoping to have the opportunity to build the bullet train in California. For those of you who have been riding light rail in Southern California, we built those trains in the 90s when they were first launched here in Southern California. Digital factory, this is a lot about what, about what Mark was talking about. This is the future of manufacturing, and process industries and drives is really the hardware and software to support automation in all kinds of industries. And finally, some of you have been pressed into a Siemens MRI, or maybe you know somebody who wears a Siemens hearing aid or has some kind of Siemens diagnostic test that was done. We are very strong in the healthcare market. I'm about to show you a video. And this video was originally conceived as a commercial to highlight our role in digitization and our role in that global technology effort that we have for data analytics and digitalization. But the way I want you to watch this video is to view this really as a crying need for STEM-based workforce development, which is really what we're here for, isn't it? Now, none of this work could be accomplished without very highly trained STEM-based workforce. We're talking about engineers, scientists, programmers, and statisticians. So let's take a look at this video. Click. Click.
Our world is becoming ever more connected. Billions of intelligent devices and machines generate massive data, bridging real and virtual worlds. Complex data now play a crucial role in the way we move, live, and work, the way we plan and create products and services. Turning the vast amounts of data collected every day into value is a key success factor for companies, economies, and entire societies. We have the domain know-how to transform the big data generated by our systems and products into rich information that enables smart choices. Our data-driven services monitor power plants to guarantee reliable energy supply. Our software and IT solutions teach wind powers how to produce more, and our building management systems teach buildings how to consume less energy. we enable our customers to intelligently automate processes across the entire life cycle of their products. And by simulating real-world objects by means of digital twins, we help them optimize their manufacturing processes. Our intelligent traffic management systems help moving people and goods faster, safer, and with less CO2 emissions. And we develop sophisticated medical imaging systems that help doctors make better decisions faster. We seize the data opportunity to create real value.
So yeah, we're great, right? But that isn't what that video is about. That video is about, wow, that's a lot of technology that needs a lot of really smart people in order to keep that going. Yeah, we want to stay competitive. We want to beat GE. But not just that. We want to stay ahead of the curve for humanity. We want to make sure that businesses have the products and services that they need to serve mankind. It isn't really just about beating another competitor or beating another company. It's about making sure we've got power for the grid. It's about making sure that we don't have brownouts and blackouts when we need power, not just so that we can play our video games, but so that we can survive hurricanes and tornadoes and get the information that we need, so that we can get people to our homes when there are emergencies or our kids to the hospital and get the diagnosis that they need. So this is about a crying need for a STEM-based workforce. Talked about a lot of really cool technologies in that video, and these are called disruptive technologies, and Dr. Mark talked about some of these disruptive technologies, and I just want to highlight a couple of more for you. So digitization, we're all about that. Artificial intelligence and machine learning, gosh, you can't go another day without hearing about some great new story about how a machine beat a human, the greatest chess player, the greatest all-time whatever, right? Artificial intelligence is huge, and how impressive to have the evangelist from Google talking this morning, because Google is on the forefront of this. Robotics, nanotechnology, 3D printing. Well, gosh, that seems old hat, right? Some of you have that in your classrooms. You've got 3D printers. And genetics and biotechnology is finding new diseases and curing them every day. So I have one more video for you, and in this next video, it talks about manufacturing, which is why we're here in this session. And the need for highly trained workers is revealed here. This sector, of course, was previously seen as lower skilled, outsourced to emerging markets. And as Mark mentioned, this is now highly intensified in brain power. So the new manufacturing worker really has to be technologically savvy. Now, granted, we're going to lose a lot of jobs in manufacturing because the people-based, hand-needed part of manufacturing is going to go away. But the technologically brain-powered part of manufacturing is only going to grow and grow. So let's take a look.
The importance of manufacturing in the recovery of the U.S. economy is clear, and analysts agree that as confidence builds, investments in U.S. manufacturing will continue to increase.
So we are now seeing an onshoring of manufacturing in the U.S. What it means for the U.S. is we'll add somewhere between 2 and 5 million jobs in the next 5 to 10 years. But they're not going to be the jobs our fathers and grandfathers did. They're going to be new, highly automated, highly skilled jobs in the production environment.
Today in the U.S., there are more manufacturing jobs available than people to fill them, with a deficit of an estimated 7 million skilled workers. Many of these jobs remain open for a simple reason. We have a skills gap.
As we go through the analysis of what the jobs and the factory of the future looks like, it's a much more highly automated factory. It relies more on cyber-physical systems that are connected together and feed data constantly. And that's what we're talking about. We don't have people with those skill sets today.
A gap in skills, knowledge, and experience in our industrial factories is driven by many factors: an aging workforce, knowledge continuity and transfer, the return to America factories which were offshored 20 years ago, and the rapid changes in technology needed to stay more competitive. Finally, skilled technical jobs have an image problem when it comes to millennials. As this generation enters the workforce, many have had no exposure to production skills, and old stereotypes have created a mass lack of appeal. So, how do we address and bridge the skills gap to keep America's manufacturers profitable and competitive? The worker of the future will need to understand automation technology, be able to enhance productivity, and work side by side with robots and other automated intelligence in a flexible and cohesive environment. That requires us to understand the competencies of our existing workforce, determine the skills needed in our new factories, and develop learning paths to close the gaps between the two. Learning has gone from just in case to just in time and is moving quickly to just enough, just for me. This requires a new way of delivering training that is immediate and on demand. Automation suppliers like Siemens can help deliver the necessary training. That's because training programs that are developed and delivered by the original equipment provider are focused on practical operation and maintenance techniques, and classroom lectures are often paired with hands-on learning using simulator workstations. This allows students to mimic real-world experiences that they take back to the factory floor to solve problems quickly. Online options are also popular and offer students immediate on-demand learning anywhere. Before investing in any training program, the supplier should conduct a learning assessment of your needs, provide recommendations for improvement measures, and identify key performance indicators. So, how do we measure competency? How do we supply knowledge as needed, where needed? How do we make production skills attractive to a new generation? These are questions we need to answer, and quickly. One thing is certain. Investing in learning programs, including apprenticeships, partnerships with technical schools and colleges, ongoing classroom immersion, and available tools for on-the-job reinforcement, will help us close the skills gap.
The skills gap. I highly recommend that everyone read the World Economic Forum's The Future of Jobs. It came out in January. It is fascinating, and it is really of utmost importance to everyone in this room who has an interest in the skills gap and the STEM-based workforce development crisis. This quote from the report: across nearly all industries, the impact of technological and other changes is shortening the shelf life of employees' existing skill sets. We heard in that video, just in time has turned into just enough, just for me. And how true is that? When we don't even know what the new jobs are going to look like, we can't exactly educate for them. We need to figure out, just as the Google evangelist said today, we need to figure out what do we want, what problem do we want to solve? Let's create skills to solve problems so that as the problems occur, we can then educate ourselves just enough, just for me, just for that problem. Because the problems are going to change. They're going to iterate. So how is Siemens adapting? Through employee engagement. In the triple bottom line, people, profit, and planet. People, certainly important. Can't run a company without them. So we need to make sure that we're engaged with our people, that they stay, that when we train them, they don't go, and that they're happy. We actually have stay interviews, probably once a quarter. Every employee sits down with their boss, and the boss says, "Why do you stay? Are you happy? What makes you unhappy? What might make you unhappy in the future? We don't want you going anywhere. Let's make you stay. Training and skill set development. Just enough, just for me, just in time. Support flexible work. Boy, isn't that a driver these days? You know, when I'm not in an airplane or someplace else in the country, I'm in my home office, in my home, actually. I'm telecommuting. And because of the new way of working, we can do this. When I go into an office, our office doesn't have cubicles. I don't have a place where I have a picture of my husband or a nice picture of the sunset. We have what's called hoteling, where we just take our laptops and we put it in a docking station, and it's just a place in the office. And then when I leave, I can put stuff in a locker, and the next day I might be sitting in a completely different neighborhood. This is called co-working environments, sharing, space sharing. Apprenticeships and internships, super important to drive this next 21st century workplace. Collaboration across and within industries. What are the other guys doing, and how are they keeping their people happy? What are they doing to generate interest and keep ideas flowing? And then what are we doing within our industries? Targeting diversity. This is so important for innovation. You can't have people who look like you and think you're going to drive innovation. You have to have people from disparate cultures, disparate races, genders, age groups. That's what drives innovation, and innovative companies know this, so they target diversity. And finally, collaborating with educational institutions. This is an imperative, and collaboration goes both ways. We need to ask of you, you need to ask of us. So I'm going to start to wrap this up. We have a sustainability education program, and I'm speaking specifically about building technologies, but all of our industry sectors do this, frankly. In our K through 12 partnerships specifically, we do energy workshops, wind, waste management, solar, sustainability, resource understanding, heightening awareness so that both the students and the teachers can raise the awareness in the classroom, not just about the importance of sustainability, because that's pretty much passé these days, but really about the science, math, and engineering behind these technologies. We have engineering career panels. We've done them in as young as 3rd grade. Students really interested in what's an engineer. So we've brought a software engineer, a mechanical engineer, a solar engineer, a wind engineer, a sustainability professional in front of as young as 3rd graders to talk about the importance of engineering in everyday life. We do professional development so that we have a lot of, maybe not a lot, but some educators who really don't feel comfortable talking about the 21st century workplace, don't really feel comfortable using the learning modalities of technology in their classroom, let alone talking about what the future of those technologies are going to be. And we also do in-kind donations of software and products and service learning so that the students can have some hands-on understanding of what technologies they're going to be facing. So I end with this slide of Angela Zhang. This young woman in this picture, high school senior. She was given a $100,000 scholarship by Siemens. We give them out every year. And the reason she earned her $100,000 scholarship is she came up with a way to kill cancer with nanotechnology. High school senior. Imagine if every high school graduated a phenom like Angela, and what an incredible world this would be. So thank you for listening, and I'm willing to answer any questions you might have.
Great, thank you, Kim. Thank you again, Mark. Time for questions. Got to have some questions. That was some really great stuff. We got one over here.
Hi, Mark. Hi, Kim. Thanks for all the information you gave. I have 3 little ones, ages 2, 5, and 7. I'm wondering, what are they going to do in the future? And so I asked them the question that Jamie was asking us today, which is, what problem do you want to solve? And I foresee that in 10 years, when my 7-year-old is 17, that she won't need a car or a license or any other thing. She needs mobility. She won't need a skilled job per se because there will be robots that she will help create. She will not need a college to go to because there might not be colleges. So the question I have is, as institutions here promoting education and commerce, how can you get out the question of what problem do you want to solve? Through your institutions and organizations, how can you promote this question of what problem you want to solve? Because she will have robots doing skilled work, and she will have other ways of learning other than in colleges, but the problems will be there in 10 years and 15 years and 20 years.
Yeah, so I think it's really important that we recognize that the world that our children are entering is changing dramatically. It's very unpredictable. So we can't train anyone for a specific type of thing. So I want to be careful when we say what problem are we solving, that we dig a little deeper when we ask that question. We need to train a workforce that's highly adaptable, that has a very strong grounding in their training, but not for a specific type of automation or a specific type of application. Because if we do that and you guess wrong, well, you're in trouble, right? So what we need a very strong foundation in our education. Now, part of that foundation is going to include things like STEM, of course, because we're entering a very technological age and we all need to be aware of that. But if we're talking about people who are going to become leaders, not just people, at their entry-level position, because our workers will be given more autonomy, they will be in charge of teams and so forth, then that education also has to include aspects that train us to think deeply about problems, not just technological problems, but how these impact the entire operations that we're doing, the community that we're involved in, and how to lead teams, and how to think about things when you don't have enough information in front of you. So that actually goes beyond even STEM. So we're talking about coming back now even to liberal arts and to the arts, because if we want to train leaders, we have to have a fuller education. So I would say the problem that we're trying to solve is not any specific thing. You might be wrong about the automation, you might be wrong about the cars and so forth, or maybe you're right, but we don't know. That's the nature of this, it's very uncertain. So instead, we want to train our students and our future workforce to be grounded in good training technologically and beyond technology, and brave enough or have the courage to adapt, to have that kind of thinking. My parents' generation, it was different. You got one job, you stayed with that job your entire life. You picked the right job, aerospace, whatever it was, manufacturing, and you would be in that job for 50 years. It's definitely not like that, but that's okay. That's just the way it is. If we have the courage and we have the experience on being able to adapt, then we'll do fine.
I'd like to build on what Mark was saying, because I think that's an excellent answer. The World Economic Forum's report also highlighted the increased need for people to enter the field of sales. Now, you might chuckle at this, but I'll tell you, as the National Business Development Manager for Siemens, I can tell you, I know firsthand that we're having a hard time getting millennials to enter the sales field, because just like many other kind of job titles, this hasn't often come with a positive connotation. In fact, even many of my colleagues who are in sales don't call themselves sales. They call themselves National Business Development Managers, right? I'm not really in sales. I help salespeople, but they call themselves consultants. They call themselves account executives, right? So the reason I'm bringing this up is because all of these disruptive technologies need explaining. They need explaining to other businesses who are going to buy them. And even if you look in this room, you know that every single thing that you see was actually sold by someone to the city of Los Angeles, who runs the convention center. And so every single one of these disruptive technologies is going to need to be sold to a business, and a robot can't do that. And so how do you explain these disruptive technologies? You gotta be kind of smart. You've got to be a thinker, you've got to be a communicator, but you've got to be a person. And you've got to be able to articulate the technology that is about to disrupt the world and help that business get a competitive edge. So your 2-year-old has got a great and promising future, no matter what ability that 2-year-old has, whether they're math-based, a great speaker, a historian, an artist. The sky's the limit. Sorry, Lynn.
Great, thank you, Kim. Other questions? Oh, got hands up now. Good. Okay.
Hi, thank you for coming today and sharing your information. I will confess this is something of a personal interest of me. It's about sustainability. And you can't predict the future, but personally, I do believe that one of the major problems starting now, probably through the next century, and maybe even the century after that, is going to be water purification. Your institution, you said, does scientific research. You have R&D. Can you just tell me whether or not your people are talking about this, finding out ways to solve this problem that will be a health problem in the coming years? We need monitors not out of the plants, not out of the water plants. We need a monitor at each faucet. This is where your machine-to-machine communication can come into play. And another thing I just want to mention, what you said about a good educational foundation. No matter what kind of computer your children or your grandchildren are going to have, chemistry is still going to be chemistry. Physics is still going to be physics. Technology will always serve the basic sciences. And I believe that's also something that needs to be promoted and taught in schools.
Well, I think water, for example, water issues and a host of environmental issues are going to become more and more important, so that is going to drive market needs. So I definitely think we're going to see a lot more activity in that direction. Generally, technology follows what the market is asking for, and so, we've had water issues all over the world for a long time, but there wasn't enough market to really drive companies like, Siemens doing work, but, to really drive that technology development. It's certainly coming online now. We've seen the infrastructure breaking down here in LA, for example. We can't even monitor the water in our pipes in our city. So now with the Internet of Things, we're going to see a lot more activity on monitoring infrastructure as well as the quality of the water and those types of things. I can't predict, exactly how that technology is going to look, but I can predict pretty confidently as that market opens up, we're going to see a lot of activity in that. I just want to echo your comment about the foundations. I'm really big on this. It's not just in, I'm a physicist. I totally agree with you about, physics is not going to change. It's going to be the same. However, it's not just physics and chemistry. I mean, it's human psychology, it's sociology, all of those things matter. Google there was a great article in the New York Times just recently that Google studied the effectiveness of their teams. And what they found is all the human dynamic. The most effective teams are teams that have people with high EQ, emotional quotient, people who understand people. They're very effective. They may be the smartest guys in the room. They may be really good at math or really good at programming, and they have a terrible performance on a team. So these foundations, we need to remember that as we. It's easy for us to get, sort of really impressed with the technology. It is impressive. But at the end of the day, it's people making that, whether you're talking about water purification or putting a man on the moon. So we have to have those foundations, definitely.
And there are limits to growth. So sustainability is about those limits to growth. There are a finite amount of natural resources. Technology is going to fill in the blanks in some of those gaps of resources, but water is one very important, but one resource. And there's many other resources that are limited. As people start to connect the dots between what's happening in their neighborhoods and what's happening globally, to echo Mark's sentiments, we're going to see a market for that, right? Business will drive, because that's the world we live in. Businesses are created when need bubbles up. And I think that's what we're going to see over and over again.
Thank you both. Got time for 2 more questions. I got one here.
Good morning. Thank you for coming. And I just I have a question. My name is Regina Todd. I work with Cal Promise program at Long Beach Unified. And I work with students they have disabilities. And I just wanted to know, what would be your advice to students who have disabilities as an effort for them to gain employment at your companies?
Specifically at Siemens? Yeah, so we have otherwise challenged people in different capacities all over. As you saw from the video that I showed, and in the 3 slides, we have 9 different sectors. We have people doing things in different capacities all over, right? So, but we are a traditional business in the sense that we have, manufacturing, we have sales support, we have salespeople, we have administration, we have finance people, we have people who support finance people. I mean, right? We're the 18th largest employer in the world, so we've got all kinds of different jobs. People typically come into our organization either because we've taken them from the competition, which is true in pretty much every accelerated industry, or we have cultivated them from the ground up. They've come into an internal. They've come in internally from a ground floor position, right? Or we have cultivated them through a program. So I'd have to speak with you probably offline to see, when people are otherwise challenged, right? They've got abilities in one area but disabilities in other areas. We want to highlight that diversity, right? Because they bring a great deal of diversity to our workforce as well. But there's different types of programs, and I just have to figure out which one would fit for you. Yeah.
Hi, I'm Bruce Noble. I'm Business Development Manager. Actually, that's the role as a DSN. But I have a question that I find challenging, and perhaps you guys have discussed it. One has to do with technology, and the other has to do with education. Is that from my frame of vision, I can see major challenges to education and what we're trying to do here with the traditional program. And I could make a case, the business case, why Khan Academy and Makers Labs could replace the traditional education model that we're trying to work towards. And I'm just curious if either of the speakers have had any discussions, or if there are any discussions about those kinds of alternative methods for meeting the workforce challenge.
Well, I think these programs that are primarily skills-based and practical training type approaches, I think we should consider them to augment our education system, not to replace it. Actually, as much as people like to bash the education system in the United States, I love it. I think the students that I get, and I get students from all over the world into my lab, the U.S. students are actually the best. And it's not because they're able to score higher on a math test. They don't. The students coming in from India or China or Korea can score higher on a math test. But they're much better at thinking independently. They're much better at being creative and taking risks. And that's what I need in my lab, because we're a very innovative lab, and that's what the workforce needs. So if we can augment these practical skills with still the kind of training that we are doing a reasonably good job at, teaching foundations, teaching students, and I'm talking about extracurricular in our high school. There's all kinds of cool things going on that teach these things beyond how to take a math test. Then I think it's great. I would see it as a way to augment our program. I don't like the idea of putting our focus just on what is important right now, Maker. That's a fun, I love the Maker movement. Maker movement may be passé in 10 years. Now what? So we got to be careful not to chase the hottest thing. Nanotechnology was the hottest thing for a while, and now it's basically died down, and there's very few jobs in nanotechnology. I do nanotechnology research. I don't train my students to be nanotechnologists. I train them to be broader. They can move in a lot of directions. So as long as if we could augment our program with these skills-based things, there's skills today that are interesting, 3D printers and things like that, to get a sense of how the world works, to get more confidence, to be able to do things, then we're a win. But if we get distracted by it, and we say, oh, this is really cool, today we're into 3D printing, let's train our kids on 3D printing, then we risk creating a very narrowly focused workforce that's out of a job in 10 years. I see this all the time. Technology turns over so fast. We have to be real careful.
And I'm only going to build on what Mark said because I have to defer to his expertise as an educator. But I will tell you, as an employee for a publicly traded company, we have a fiduciary responsibility to our shareholders. And our shareholders don't want us to, let me rephrase. Our shareholders want us to stay in our core competency, right? Buzzword. They want us to do what we're good at. And what we're good at is training the employees for the things that we currently do right now. Just in time, just enough, just for me, right now. But what we want to make sure is that we're meeting the goals of our shareholders, right? This is capitalism at its finest. Our shareholders want us to make a profit for them, and getting into the education business or supporting anything outside of our core competency wouldn't really be to the benefit of our shareholders. Now, that's kind of the ugly truth of capitalism, but what we do is invest $90 million in workforce development and $7 million a year on education and scholarships and grants. And by doing that, and by allowing me to not work for Siemens today and come and speak to you about our education partnerships, we are in this together 100%. And our shareholders value that, and we know that we have to have a STEM-based workforce in order to stay competitive, and our shareholders care about that too.
Great, thank you. Sorry, we're out of time for questions. What a great note to finish on. Please give me a welcome hand for Mark and for Kimberly.